Alright guys, I'm going to go through the questions on the proficiency review. We're going to start this video with just the first couple, and we'll split it up in a couple different videos here. Number one, find the solution set of this absolute value inequality and show the solution on number line. So it's already, the absolute value is already by itself. Okay, there's nothing else over here, so I can go ahead and split it into two cases here. X plus 3 is, just write it as is, there's one of them. And the second case, x plus 3, switch the inequality, make it a -8. And now you solve these two separately. So subtract 3, x is less than or equal to 5. And x, let's see, subtract 3. X is greater than or equal to -11. Okay, so on a number line, those are your boundary points. 5 and -11, the boundary points. So this is -11 over here, this is 5 right here. These are open circles. No, there's a little or equal to right here, so let's fill them in. And then it says x is greater than -11 and less than -5. This is an and situation, so shading's between these here. Alright, so there's number one, and our number one solution. Number two, solve and graph the solution set. Now notice there's still one variable here, so my solution set will be in a number line, like last problem. Now, the way we've been doing this in class was just treat it like there's three sides to an equation here. So you want to get x by itself, and right now the things keeping it from happening are this 3 and this 3. So think to yourself, what's the opposite of plus 3? It's minus 3. So that's what we do to everything. To get rid of it from here, let's see, 12 minus 3, that's 9, is less than 3x. Is less than 18 minus 3, that's 15. Okay, right now I have 3 times x. I need the x to be by itself, so this is not good enough yet. How do I undo 3 times something? You divide by 3. So this becomes 9 divided by 3 is 3, is less than x, is less than 5. So here's my number line solution. I got 3 here, 5 here, open circles, correct, yep, there's no or equal to, so open circles, and shade it in here. There we go. Now feel free, whenever you have something like this, you want to pick a test point, you know, like plug in a 4 up into the original equation up here. Well, let's see, 3 times 4 is 12, plus 3 is 15. Is this true right here? When I plugged in a 4 as a test point, is that true? Yes, my shading is correct when I plug in a 4. So let's just, in the test point, check my answer. That's number 2. Moving on. Number 3. Okay, it's another absolute value inequality, but I need to see the absolute value is not by itself yet, though. I need to move this 8. What's the opposite of plus 8? Okay. So now I have this. See, that's 20. So I have 2x plus 4. Okay, now I've got absolute value is by itself, nothing else on the left side. Split in two cases. So I got 2x plus 4 is greater than 20, as is. Second one, do 2x plus 4 less than -20. That's the trick. And then just solve both of these. So 2x is greater than 16, so x is greater than 8. Over here I got -4. 2x is less than -24, so x is less than -12. Alright, and number line there. So x is less than -12, so here's -12, open circle. X is greater than 8, there's 8, open circle. So less than -12, I shade to the left, that's the left side, and greater than 8. Alright, and again, if you want to get a test point, you know, 0, if I plug in a 0 to the original, it should not be true, because it's in this region right here. So try it real quick. Let's plug in a 0, see what happens. Let's see, 2 times 0, that's 0 plus 4. Absolute value of that is just 4, plus 8 is 12. Is 12 greater than 28? No, it's not, so I'm correct to say that my shading does not include this area here. Because when I plug in a 0, it made the original statement false. Next, I got number 4, solve and graph the solution set. Now, this says or, so this is most likely going to be where the shading is to the left and to the right, not between. So we'll see if that if that's the case. Oops. Sorry about that. Make sure they're still working. Yep, good deal. Okay. Sorry about that. So I'm just going to solve these two separately. This is compound inequality. Just going to solve them separately, put my answer together on one number line. So over here, just get the x by itself. Let's add 9, add 9. So 3x is less than, let's see, negative 21 plus 9. Is it going to be negative, what was it, negative 12, right? Right, 12 plus 9 is 21, good deal. Divide by 3, x is less than negative 4. Okay, over here that is a 6. Yes, okay. Let's see, I need to get x by itself. Right now I have the 8 and the minus 6 keeping that from happening. So what's the opposite of 8? Minus 8. So let's subtract 8 over here. Negative 6 is less than, or sorry, negative 6x is greater than or equal to negative 18. Alright, be careful. You've not seen this happen yet. Negative 6, I need to divide by that, because that's the opposite of negative 6 times x. But when you divide by negative in inequalities, you flip your inequality sign. That's what that is right there. I flipped it, because I divided by negative. Negative 18 divided by negative 6, it's 3. Alright, so let's see what that looks like on a number line. Careful. You got, one will be the open circle, one will be a closed circle. So let's see that. Here's a negative 4, open circle. 3, closed circle. Be very careful about that. One's open, one's closed. X is less than 3, and x is less than negative 4. I don't see a lot of these. Let's see, x is less than negative 4, and x is less than 3. So this is a funny looking answer. I'm going to go ahead and check it here. So let's see. As you know, when you see something like this happen, you're just going to red flag. Let's see what happens if I were to check my answer by graphing. See, 3x minus 9 is less than or equal to negative 21. 8. Oh, no, wait a minute. 8 minus... okay. 8 minus... I typed in the calculator wrong here. 8 minus 6x is greater than or equal to negative 10. Yep. Alright. Yeah, sure enough, that's correct. So see, I just graphed it right here, separately. And there's my open circle right there at negative 4, and then my closed circle at 3. And there you go. Yeah. Okay, so that was number 4. Let me just check that in the calculator. Let's do 5. Right, okay. So, think about how absolute value really finds distance. Finds distance. That can be positive or negative. The point is it finds a distance. Like, if I said a distance from 2, you could go above and below. But I don't care about above, like if it's above or below. I just care about the distance. I could go 3 above or 3 below. But ultimately, that distance of 3 is a positive idea. So let's pause this problem here. The basketball needs to be 8 to be properly inflated. So I'm going to just draw a little number line here. Here's 8. This is saying it could be within 0.25 of 8. So I got 8.25 here. And this would be 7.75. I only figured that out just by going up from 8 2.5 and down from 8 2.5. So if I were to graph my answer, this is what I'd see. Okay, so that might help. Maybe you can build backwards from that. So let's see, right? An inequality. I'm going to call, let's see, let's call it P. Let's say P. So if I take P, this variable, say it's like 8.1, right? It could be in here somewhere, and subtract 8, that will get me positive or negative distance from 8. Say if it's 8.25, 8.25 minus 8 gives you 2.25. But if you take the absolute value, that'll make it a positive. Okay, so that, again, absolute value finds the distance. So basically all this is right here is saying P is how far from 8. Okay, well, how far can it be from 8? Well, it has to be within 0.25. So less than or equal to 0.25. And that's actually it. And if you were to get this in a number line, it'd look just like that. Okay? Alright, on to number 6. Now number 6 is, 6 is in the calculator here. So Make sure that if you're using TI, you solve for y, but it just says find two coordinate points that lie in the solution. So I'm going to graph these two here. Let's see, this is number 7, so I got 2x, here we go. Yep. 2x minus y is greater than equal to 4, and 6x plus y is greater than 6. All right. So remember where they overlap, where the shading overlaps, that's where the solutions are. So I'm just going to pick 2 points in here. Let's just keep it real simple here. 1, 2, 3, 0. So let me write these down. I got 3, 0, and 1, 2, 3. That's right there. And let's just do 3, 1 also in there. And let me go ahead and put these in decimals actually, just so I can see them show up on here. I got, like I said, 3, 0, and I got 3, negative 1. So those 2 points right there. See how they're in the double shaded region? So just 2 points in the solution set of those inequalities. Okay, let's look at, did I skip number 6? I think I skipped number 6. Let's go back to number 6 then. So number 6 is just graph this system of inequalities. I already got it set up over here. Greater than y is greater than 3x plus 1. Y is less than negative x minus 4. I'm just going to graph those two things. And remember, the solution set is where the double shaded region is. So again, we cannot show this any other way. We have to just say by graphing. So this region right here, the double shaded region, that's your answer. That's your solution set. Okay, and then the last one we're going to do in this video, number 8. Graph the solution set to 3 graphs. So I've got them down here already. It says y is greater than or equal to x, y is less than 9, and y is greater than or equal to negative 0.5x minus 5. So now check it out. Your solution, let me turn this up some. Oh, it's pretty bright enough. So your solution set is this shaded, this triple shaded region here. So again, if you were to like sketch this out, so let me do that real quick here. If I was to sketch out what this would look like, I mean, I would just sketch these lines. So let me get this paper here. I would just sketch these lines. There's one kind of like that, one kind of like that, one kind of like that. And then the region, the solution region, is just that region in there. Okay, so even though you see a lot of those shading, the only answer is that one right there where the 3 overlap. Also note, you've got a dotted line right here, and then these 2 are solid lines. So you also have to be careful about that. That one, this is technically a dotted line. And the others are all solid. Okay, so that is the end of this first video. You'll have to watch others to get the solutions to the rest of the problems.